Hi everybody, I wanted to do just one more example of how you write complete ionic equations as well as canceling out spectator ions and then finally figuring out your net ionic equation. And this is the example that I have for you written on the board. We have iron 3 chloride that's an aqueous solution, and that's reacting with an aqueous solution of potassium hydroxide, and when those two react we'll produce iron 3 hydroxide that's a solid, and then an aqueous solution of potassium chloride. So you'll see here that we have our reactants, we have our products. You would have used your solubility rules to have determined if something was soluble or insoluble. So we knew that hydroxides are insoluble, that gives me a solid, and I know that halogen, which is chlorine, and those are soluble, and that would be an aqueous solution. So the next thing I want to do is to make sure that my equation, my chemical reaction, is balanced. So let's make sure that this is a balanced chemical equation. And off the bat, I can tell you that it is not. We have 3 chlorines here, but I only have 1 on that side. I have 3 hydroxides, but I only have 1 hydroxide ion on this side. So if I were to balance this, I would do a 3 right here. And I would do a 3 right here. So now I have a balanced chemical reaction. The next thing that I want to do is write out the complete ionic equation. By writing out your complete ionic equation, that means that we're going to show all of those aqueous solutions dissociating into their ions. So any aqueous solution that I see, I'm going to have to break it apart into its ions. Can I do that for a solid, a liquid, or a gas? I cannot. So if it's a solid, if it's a liquid, or if it's a gas, I'm not going to be able to break those compounds down. I can only dissociate aqueous solutions into their ions. So let's look at our first reactant. It is an aqueous solution, so I'm going to have to break that down into its ions. So I would have iron with a +3 charge, and that's aqueous. And then the anion that it will break down into is chlorine, but look how many chlorines you have. You have 3 of them, so I have to account for that. So I have 3 chlorine, -1 charge, ions. The only reason that I wrote that 3 there was because that 3 is next to chlorine, so I have to account that I have 3 chlorines. The next solution that we have is potassium hydroxide. It is also an aqueous solution, so we're going to have to break that down. But there's a coefficient in front of it, and I have to account for that coefficient being in front of that as well. So I'm going to write potassium, but how many potassiums do I have? I have 3 potassiums. So I'm going to write 3 potassiums. They have a +1 charge. They are aqueous. And I'm also going to have to write my anion, which in this case would be hydroxide. And how many hydroxides do I have? I have 3 of them. So I'm going to have to write 3 OHs with -1 charge. And that's aqueous as well. Okay, now I need to look at my products and do the exact same thing. Iron 3 hydroxide is a solid. Am I able to break that down? I am not, because it's a solid. It's not an aqueous solution, which means it will not dissociate into its ions. So I'm just going to continue to write what I had there as my solid. Just going to bring that down. Okay. Now, the last solution that I have left is potassium chloride, and that is an aqueous solution, and I can break that down since it's aqueous. So, the cation is potassium, and how many potassiums do I have? I have 3. So I have to write 3 potassiums with a +1 charge. That's aqueous. And then my last one is chlorine, but how many chlorines do I have? I have 3, so I'm going to have to write 3 chlorines with a -1 charge, aqueous. Okay, so we have completed our complete ionic equation. The next step that we need to do is cancel out our spectators. So now we want to cancel spectators. Want to get rid of those ions that are the same, the exact same, on the reactant side and the product side. So if I look here, iron with a +3 charge aqueous, do I see that on my product side? Exactly the same thing. I do not, because iron on the product side is still bonded with hydroxide. I can't touch it because they're not the same things. So iron won't cancel out. On the reactant side, I have 3 chlorine ions. If I look on my product side, I have 3 chlorine ions. So those are the exact same. Those can be canceled out. I have 3 potassiums with a +1 charge that is aqueous. On the product side, I have the exact same thing, 3 potassiums with a +1 charge that's aqueous. That means it must be a spectator. I can cancel that out. Hydroxide on the reactant side, I don't see the same exact thing on the product side, so I can't cancel that out. So we canceled out our spectators. The very last step is to write your net ionic equation. And all that means is I just have to write what I have remaining after canceling out those spectators. So I have iron with a +3 charge, so I have Fe with a +3 charge that's aqueous. And that's going to react with 3 hydroxide ions, which is aqueous, so -1 charge. And that will produce for us iron 3 hydroxide that's a solid. Okay, so now if I look at my net ionic equation, I just want to make sure that this makes sense. Do my reactants really truly make my product? I have iron with a +3 charge. I have 3 hydroxide ions. So if I have iron and hydroxide, I should make iron hydroxide, specifically iron 3. That's what I see over here, so it looks good. I want to make sure that this is balanced. Because you balanced your equation up at the top, we started off with a balanced equation, we ended with a balanced equation. So I have 1 Fe, 3 OHs, 3 OHs, so we're good. So this would be our last step, and now you're going to get a worksheet that's going to go through that I want you to do the following things. I'm going to give you reactants, I want you to determine the products, and I also want you to determine their solubility. So that means on the products, are they going to be a solid or will they be aqueous? Then you're going to balance your equations, then you're going to write the complete ionic equation. You're next going to cancel out your spectators, and then finally you're going to write the net ionic equation for me, okay? If you do not finish your worksheet in class, it will be due for homework on Tuesday, and it's due at the beginning of class. So I will see you guys on Tuesday, and I hope you guys have a really good day. Bye!